third and final Coulomb's law example problem. A familiar situation. It's the same situation as example 1, except that we have a different system. We're looking at what's going on with QC. Now, as I noted in example 1, B is 5 centimeters away because this is a 3, 4, 5 triangle. And I'm going to also note my positives and negatives. Positives for C, negative for B, and positive for A. All right. So I have drawn the situation, noted the trigonometry, identified the system. Oh, I should probably note one more thing about the trigonometry. It has to do with what is this angle here, and that's going to be the inverse sine of 3 over 5. Okay. Being the inverse sine of 3 over 5 means that we have second inverse sine of 3 divided by 5 makes us 36.869 etc. degrees. So I'm going to call that 37 degrees. All right. Forces. I'm going to do A on C first. A on C is going to be a repelling force, and it's going to be pretty small. Force of A on C. Okay. B is going to be an attractive force because it's negative and C is positive. So that's going to be, I'm just drawing it just off to the side of the other line so it's easy to see it. B on C. Which means that I'm expecting the net force to be a little bit right, but mostly down. Okay, that's my expectations. Okay, forces are drawn. Use trig and Coulomb's law to find the components. A is easy because it's completely in the x direction. Force of A on C is equal to KQA QC divided by R squared in the x direction. 99. QA is 1e negative 6. QC is 3e negative 6. And R is 4 centimeters, 0.04 squared. Grabbing my calculator. There we go. I get the same result as I did previously, which is 16.8. 16.9 newtons to the right. Why previously? Because previously we found the force of C on A in example 1. Now we're getting the force of A on C. So it's the same magnitude, except this one's to the right. C on A was to the left. Gonna get my spot to write these all out. I got my A on C's, and then I'm going to have my B on C's. And A on C is not in Y and completely positive in X. Beyonce. Magnitudes. B on say K QB QC divided by R squared is equal to 9E9 2E negative 6 3E negative 6 divided by 0.05 squared. Giving me 21.6 newtons. But we gotta break that into X and Y components. The X part is gonna be to the left. Okay. We're dealing with something that is not just at 37 degrees, but it's at 207 degrees. Correction, 217 degrees. Okay, I got that by taking the 180 and adding 37 to it. So the X part will be 21.6 cosine of 217 degrees. And the Y part will be 21.6 sine of 217 degrees. 1.6 cosine of 217 gives me negative 17.3 newtons. I'm expecting to the left, that's a good thing. Negative 17.3 newtons. And in the Y direction, I'm expecting a negative number here. And I get negative 13 newtons. The force electric on C is going to be negative 13 in Y. And it's going to be negative in X, which is a little off from what I said earlier. It looks like I did not draw the two forces to scale earlier. So either the blue should have been drawn shorter or the red should have been drawn longer. So not exact, not quite. So I'm doing my double checks as I go along. 16.9 minus 17.3 gives me negative 0.4 newtons. So we do get something that is down, but it's actually a little bit left, not a little bit right. That seems reasonable, actually. It actually does seem quite reasonable. Polar coordinates. Magnitude of F electric on C. It's going to be this squared plus this squared, all square rooted. So 0.4 squared plus 13 squared, all square rooted. It's going to basically be 13. 13.006, it's 13 newtons. And the directionality, I'm expecting basically straight down. I'm going to do the, it's in the third quadrant, so I'm going to have to do an adding of 180. Inverse tangent of negative 13 divided by negative 0.4. And I'm expecting something very close to 270. And I get 268 degrees. which is very close to 270. There we go. We got a result in polar coordinates. We got our result in Cartesian coordinates. We're good to go. Hopefully this is enough so that you can go back through and do the additional practice problems on your own. Good luck.